Okay, today we'll try to see Ramjet engine and the missiles which run by the Ramjet engine. So Ramjet engine is nothing but air breathing jet engine. So you can see here there are no moving components are available. And there is advantage with the Ramjet engine. You can carry only the fuel. But if you see in rocket engine, so we need to carry both fuel and air. Liquid fuel and liquid oxygen we need to carry for the rockets, but whereas the ramjet engine we need to carry only air, fuel. Air was taken from the atmosphere, so the air was taken by the forward motion of the aircraft or a missile. So you can see the compression was taking by the ramming effect. You can see ramming is nothing but if you have a these are the waves. Okay, these are the waves which have a gap between them. So if you apply some external medium, or if you restrict these waves by some means, then what will happen, these waves the gap between the waves will be decreases. So this is nothing but ramming effect. The geometry of the ramjet engine designed in such a way that the air was compressed by the ramming effect. Okay, now you can see the ramjet engine have a four main steps. First one is a air intake, compression, then we have a combustion, then we have a exhaust. Air intake, where high speed air is entering into the intake of the ramjet engine. Whatever air it was entered, that was compressed by the ramming effect. That is the due to the shape of the ramjet engine, the air was compressed from the low pressure to high pressure. So here you can see there are no moving parts are available in the ramjet engine. The compression is taking place the ramming effect, whatever I shown in the earlier slide. So definitely there are no moving parts, so the noise also decreases. Now after entering the rammed air at the combustion chamber, fuel was injected from the fuel injector. So ignition was taking place. Combustion was obtained. So there it generates high temperature and high pressure. Hot gas are generated. These high pressure, high temperature gases are relieved from the convergent divergent nozzle. You can see at the exit we have a convergent divergent nozzle, and due to this shape of the convergent divergent nozzle, so whenever these hot exhaust gas are relieving from this nozzle, a huge thrust is generated. So due to that one, so the missile or aircraft which will be moving in the forward direction. So these are the four parts of the ramjet engine. So you can see the ramjet engine is works optimal at 2 to 4 Mach number. So Mach number is nothing but it is the dimensionless number, which is the velocity of the object by velocity of the sound or sound velocity. So if you are talking about missiles, Mach number is nothing but velocity of the missile by the sound velocity. So it will be effective at 2 to 4 Mach number, and it will be effective at an altitude of 15 kilometers to 25 kilometer. At this altitude, the ramjet engine is very effective. So you can see the latest missiles which was run by the ramjet engine with BrahMos YJ-15 P800 Onyx, or it may be called as Yokant CM-10 Bomark. So the BrahMos is a collaboration work by the India and Russia. YJ-15 it was developed by the China, and Yokant which was developed by the Russia, and the CM-10 Bomark which by USA. Okay, we'll see. This is the BrahMos, which was developed by the Russia and India collaboration. You can see this is the supersonic intake part. Already said the ramming effect, which was done by geometry. So whenever air is entering at high velocity. So this was uh, going to touch the supersonic. This is the ramp, this is the curve. When it is touches in this pattern, the velocities decreases and the pressure increases. So due to this geometric ramming effect, the high pressure is air is travel to the combustion chamber where combustion is taking place, and at the end we have a solid booster to attain the uh, cruise condition for the BrahMos missile. Okay, if you want, I can show you a 3D view of the BrahMos. You can see this is the 3D view of the BrahMos. You can see this is the nose. We have a cowl and ramp, and we have at the end you can see. So we have solid booster. Okay, this is the solid booster. After expelling of solid booster, the complete ramjet engine will be in on condition. Okay, so this is the 3D view of the BrahMos missile. Okay, then we have a YJ-15. We can see in BrahMos, you can see the air intake system is available at here. But if you see YJ-15, so this is the air intake system which is available at this side. This one and two, we have a another in the other side. So there are these are the intakes, air intakes or supersonic intakes, which is available at the side to the YJ-15. Then we have Yokant. We can see this is very similar to, because Yokant was developed with Russia. So the BrahMos and Yokant are very similar. You can see. So there is a difference in the altitude and Mach numbers. The shape almost they are very similar. You can see here. Then we have a the CM missile which was developed by the USA. Okay. So this is about Ramjet engine, how it is important, and what type of missiles are run by the Ramjet engine. Thank you.